In this example, we're going to integrate square root of w plus 2, which is going to require substitution, but we have bounds. So let's start by letting u equal w plus 2, then du is just dw. And now we need to translate the bounds, because these bounds currently belong to w world. So we'll plug in negative 2 and 0 into u equals w plus 2, so that we get the u values that we need. Then we can write the new integral entirely in terms of u. So we'll integrate from 0 to 2, because those are u values, instead of negative 2 to 0, which are w values. And then we just have the integrand of root u, which is u to the 1/2. So we can do the antiderivative, start with the exponent, add 1, we get 3/2, multiply by the reciprocal, which is 2/3. And now we don't need to translate back to w world because our bounds are already in terms of u. So we just plug in the 0 and 2, and away we go with the computation, the algebra. So this is one way to handle the bounds for integration using substitution on a definite integral. If you don't like the idea of translating the bounds, you could always take the approach of leaving the bounds in terms of w, but you must denote that these bounds belong to w. Otherwise, you've written an entirely different integral which has a different meaning. So in this case, we've clearly pointed out that the bounds negative 2 and 0 belong to w, even though we're integrating with respect to u. So once we get our antiderivative, we now have to translate back to w. So we plug in the w plus 2 for u, and now we can proceed with the fundamental theorem of calculus, and we will end up in the same place.